don't put that in the tool.
Okay, like yesterday, even today, I'll take the attendance in the end. Okay, so can anyone tell me what did we discuss? Okay, not what did we discuss. What did I give you last class to research on? Please, fast. People who are present, I need you to tell me what did I tell you last class, and did you see that any one of you? Biases, yeah. Did you check about those? So from today onwards, whatever I tell you to search, I won't be teaching again in the class. Okay, because in your syllabus there is some amount of self studies, and that self studies should be done by you. And here I'm telling you which topic you can self study. So please do that. 35 are present right now. I'll wait for 2 more minutes for everyone to join. Okay, I don't see people joining. Shall we start the class?
Yes, sir.
Okay. Yes, bias are human prejudice when it comes to AI, but in data science, a little bit quite the definition is little bit different, but in the end, it's doing the same thing. Okay, yeah, you're almost there. Just need to dive little bit deeper. Okay, I'll start the class. Today we'll begin with the notebook itself. Okay, so I've created the notebook for day 4. Okay, today someone was asking me for them the notebook was not opening. What I sent in the WhatsApp. So I wanted to reply you, but I couldn't because I was in work. Okay, I'll tell you how to. I'll tell everyone that how if someone is facing the problem that the notebook is not opening, just upload that notebook to your Google Drive. From there, you try to open with the collab. Okay, it will open most of the time. Or else you can just come to collab. I'll show you what to do. Can you see the screen? Okay, nice. Okay, let's start today's. Okay, before we start today's class, I'll tell you how you can open. Just normally you open the collab and it will be in your local drive, right? So here there is an option called upload drive. So when you come to upload drive, it will ask browse. So from this, you can just go to whichever the Jupyter node. See, this is Jupyter notebook source file. So if you click that and open it, the notebook will open. Okay, so people who had doubt, you understood, right, how to open it. So how many of you could open it, could open the file what I sent in the morning? Just raise your hands. Okay, only three. Okay, five, six, seven, seven. Okay, so you opened, right? Okay, what about rest? There are 44 members and people have not opened the file I sent. Okay, there are nine. It's quite low, but you have to do a self study. Okay. So, anyways, we'll start continue with the today's class. So, as I said, from today onwards, I won't be continuing what I give you for research. Okay, because you have to do self study, and I guess most of you are not doing the self study. So, let's start with today's topic will would be EDA. So, what is EDA? Do anyone of you have idea what is EDA?
Sir, exploratory data analysis, sir.
Yes, exploratory data analysis. Uh, yeah, you basically said the full form. I was asking, do you know what the definition means?
So basically, in this, we actually explore the data in such a way to make more information from the current data that we have, sir.
Yes, which is nothing but visualizing the data. It could be anything. It could be a summary. It could be a graph. Okay, so that is EDA. So here are the definitions in this. You can study that by yourself. But I'll tell you. So EDA is the process of summarizing, visualizing, and understanding the main characteristics of dataset. So before we could apply any of the statistical or predictive techniques. Okay. So that's the easier summary or the definition of EDA. So uh, so what is the key purpose of EDA? The first purpose is understanding the distribution. Okay. Then detecting anomalies in the sense outliers in the data. So I guess you know the terms outliers. I hope you know it. Okay, nice. Okay. So next purpose would be identifying the patterns, then deciding what are the analysis possible in those data. So that is the purpose of EDA. So even EDA is nothing but it's about asking the right question to solve. So at its data science or data analysis at its core, it's nothing but critical thinking and asking the right questions of the data what you have. So okay, why EDA comes after data cleaning? So yesterday we learned about data cleaning, right? How can we clean the data and or how to find out whether you have to clean the data or not, right? So why does EDA could have been even in beginning itself because it's just visualizing the data. But why after cleaning? So the like dirty data is always you will always get the misleading plots. Like I said before, when you have a when I gave you the example of my company and we had a male and female that plot. So when there is a different kinds of categories in mail itself, like mail in caps lock and or just young, so you will get the misleading plot if you draw it. So you will be getting the two different plots for mail itself. So one will be mail, one will be just yum letter, or one will be in caps lock. So that is nothing but a misleading data. And why we have to do after cleaning, another reason is most of the time missing value will what missing value will create a blank space or a break in the graph or in the line graphs or pie charts. Okay, then third last reason why we have to do after cleaning is because of the outliers. So outliers are hidden most of the time. Without cleaning the data, we cannot identify the outliers and do the EDA. So what are the what is distribution or numerical data distributions? See, I have given by after cleaning here. Okay, so for people who miss the class, here is the detailed explanations about it. But I have explained it in very short manner so that you could comprehend. But if you want me to read this, I want a thumbs up. If you don't, then please send me thumbs down so that I can continue with the current phase. What are you doing? I don't get any replies. I don't get any answers. Okay, just tell it in the chat. Or do you want me to explain what's in the notebook, or do you want me to tell what I know from my knowledge? Okay, now the thumbs up, it doesn't make sense. When I told you to do the thumbs up, nobody did, and now they are making thumbs up. Shameless people. Just put it in the chat, guys. Because okay, okay, I'll continue with the face. I won't be reading it. Okay. Let's continue. Next will be uh, what is okay. Let's come to numerical data distribution. So distribution describes how values of a numerical variable are spread across the range. So what are the best question you could ask for distribution? Like uh, where do most value lie? In the sense, like or how spread out are they, or are there extreme values? For example, see, understanding the distribution is here. See, the right questions we could ask is what do the most values, where do the most values lie? For example, let's take the housing rent example. And most of the time, there will be an average rent, right? So, but in extreme cases, there will be two or three cases such that for a cheap, low cost houses, the listing of the price would be high, which is which is wrongly categorized, but it will be high. But we cannot say that it's wrongly categorized because we don't know the actual reality. So what happens? At that time the distribution of data becomes it will be you have to understand from where to where it ranges. So that's what basically a distribution means. Okay. Next, coming to like practical setup, we have this here. Okay. So this is a some yesterday or day before yesterday showed you the student performance CSV, right? So from that I have taken the summary. So here student ID. So here when you describe something, it will give you the uh, mean of everything, which sometimes not required. So if I take the mean of your USN, it's uh, it's quite not required, and it's waste of time altogether, right? So it has done the same thing here. It has given the student ID counts It has given the mean of it, which is not required. Same standard, then it's minimum, then it's same 25, 50, 75% uh, median. So, okay. See here, here what actually count represents is non-missing values. Okay, in the sense, if any value is, we would be knowing what are the values before we when we do head or shape of it, right? So after that, when we do describe, the count is nothing but the non-missing values. So here you can see everywhere the student ID or the weekly self study hours, attendance percentage, class, everything is same. But when it comes to total score, it's uh, like one is less, right? Which means here in total score, one of the value is missing. Understood? That's how you read the data. Next, here when it comes to mean is nothing but the average score. So here student ID average is not required. But if you considered what weekly self study students do, that is 15 hours. So that is that might be required when you do the dashboards and all, right? The mean of the weekly hour study if we take this data set. Then attendance percentage. So in this described summary, you can understand count, which is you understand non-missing values, how many non-missing values are there. Mean, you can understand the average score or anything, average of anything. STD is nothing but the spread or variability. Then min and max are nothing but the extreme values. So minimum student ID here is 1 and the extreme last student ID is this here, and you can see minimum some students don't study at all, so which means 0 hours of study, and maximum there are people who are studying 40 hours and all, which is ludicrous. Okay. Then attendance percentage, similarly people who have like minimum percentage there is 50 and maximum is 100. So here what you can understand is in the mean and all, like do this average look reasonable? Sometimes the average look doesn't look reasonable when you look at the data. So you can make figure out it from here. And uh, like sometimes we will be having minimum attendance percentage, right? So if it, for example, let's take it here. So minimum was 50% itself. So if it was below 50, then like the school is now irresponsible of the students and they are not telling the students to have a minimum attendance, right? So that's what you can understand from this. This actually I told you yesterday too, but I haven't explained these what it means. So today I told you that. See here the interpretation I have given clearly. Okay. So STD is nothing but standard deviation, which is spread or variability. So when you explain it to your colleague data analyst, you say standard deviation. But when you explain it to your management or someone who is from non-technical background, you say it spread or variability to understand it better. Okay. So here is the first quarterly median, which is second quarterly, then third quarterly. These are the percentiles. So which most of the time we don't use those for insights, but you can see here uh, these are used in the businesses, like business revenue generation, what you see, right? Generation data set, there you'll use these because there you'll be having in the first half of the or first quarterly how much revenue is generated, or in the 50% or in the half year how much revenue is generated. So at that time we use for these for insights. or else it's quite we don't use it for the insights. Okay. So till here, the key observations what we done was we confront that like what are the missing values into like there is a missing value in total score. Then student study habits we have like we got the insights of student study habits. We also got the insights on attendance. Then participation, like class participation score, it ranges from 0 to 10, and the average here was 5.8 8, right? No, 5.98. Okay, so that's what we did. So let's coming to outliers. So before coming to outliers, uh, oh, you understood the previous parts, right? And how to look at the data and what are the commands we have here to do the EDA. So EDA yet to come, but this is the first step to do the EDA. Okay, there was supposed to be a histogram. One second, did I miss it? Okay, for some reason outlier has came up. One second. Okay, there is five missing, I guess. Four summary, five. Okay, five is histogram. Okay, coming to histogram. So you know all you know about histograms, right? So we'll from here onwards we'll start to learn about the visualization. So how can we how the distribution works. So most of the time the distribution is looked at with the help of histograms. Histograms, I guess most of you know, but I'll still explain you what are histograms. Okay. So it shows how frequently value occurs within the range. So this is the actual definition of it. But in simple words, it will show you how frequently any value occurs within a certain range. Uh, so when is histograms used? So histogram is primarily used for visualizing data, as I said. So when it's helpful, useful. So it's useful when we have to understand the data shape. For a data shape, in a sense, how many columns or how many rows are there. Those kind of information we can use histograms. Okay. Then to identify central tendency. For example, I guess you might have seen histograms during the election time in the news channels. So they will be putting up the graph for each and every party, right? And they're putting up the percentage or the percentile. So that's what histogram is. I guess I don't have to explain more about histograms, but why it's used, why and when it is used, I have given it clearly here. Okay, so rather than me telling, if you explore and see this, then you'll understand even more better and will be able to remember it for a longer time. Okay, so after see, this is how histogram look. Okay, this histogram is for it shows the total score distribution. So here is the frequency and here is the total score. Frequency is nothing but the number of students and who has how much scores. Here see, distribution of total score, we have given total score and in the x-axis we have given total score, which is there in the data set, and frequency, that too it's there in the data set. So I'll share you the data set today in the just remind me if I don't share. Okay. uh, See, this data set is quite confusing because It's for the beginners, but it's quite intermediate level data set. So it's better if you understand this rather than starting from the beginner level data set, because anyway you have the detailed notes here. Okay, so you can refer that notes and look at the data set or to understand the data set. So once you can understand intermediate data sets and what are the things you can experiment with, then it's child's play. So here the total score, what it provides is the shape. So we know the total score ranges from 0 to 100 because it ends at 100, right? And so we can also know the central tendency. So while exact mean is 84.28, so and the median is this much. So here the visualization is representing properly, right? So see, you can see this line going, and where is it its where it is its peak and where it is at its median. You can see here, and where is it at its mean. So peak, there is a peak point which is nothing but mode. So in this 90 to 100 is a 100 maximum score range we have. Okay, so the peak range starts after 70 to 80. So this is how the histogram gives you the data. I mean insights, but this can be even more made even more in a different manner as well. Okay, this is one kind of histogram. Now coming to outliers. So today I'll be just telling you what are the things we can do. So in after 2 or 3 weeks, we'll just do about just uh, solve or do practicals about for one data sets, and you will bring the data sets. Okay, so what we'll do in that sessions, you will bring me data, and I'll pick 2 or 3 data in 1 hour. Then we'll do some data analysis or data handling in those. Okay, so if we understand the concepts now, like even the basic concepts, then it will be easy when we do it later. We ask the so that I don't have to explain. At that time, we can just discuss on the data set what we can do, and we can just uh, experiment there. So you'll be thorough with the data analysis part or data science part. So okay, let's come to outliers. Okay, see, so outliers are nothing but is a data point that significantly differs from like from the majority of the observations. So for example, mm, in the school or in the okay, let's take in college, there are around 100 students. Out of 100 students, everyone's age group it ranges from 20 to 24. So in that range, there will be around 4 to 5 students whose age group is around 28 or 30. Let's just assume that. Okay, so those are the outliers. So outliers doesn't have always have to be that those are the wrong data, but outliers are something which sometimes makes the as you can see here in this. So one or imagine it with the same data set. There will be the graph will be going in a smooth manner, but at one place it will suddenly hike and get down, right? So when you look at it, you'll feel something is off. So that's what the outliers are. So yeah, example would be the topper student. Here the example would be topper student is an outlier. Because see, out of 60 students, there will be only around 10 to 10 to 12 uh, good performers, and even that in that 10 to 12 good performers there will be three or four like topper students. So what happens, everyone's CGPA is in around 7 or 8. Suddenly for the top students the CGPA is around 9.8 or something, right? So at that time he becomes an outlier. So it doesn't always means the data is wrong, or we have gotten the wrong data set, I mean data entry. Okay, so you got the basic idea of outliers, right? No thumbs up, nothing. Yeah, Sandesh, I get the thumbs up of same people. Okay, so this is about outliers. See, I have also told you why outliers are not always an error, because see, I just explained in a very uh, layman's term. Here it's given in a proper way, okay, and also in a detailed manner. I want you guys to read, because I feel that you are not reading enough. It's a it's a best trade and data analyst can have, which is reading, because you have to deal with lot of reading. Okay, because I haven't got any doubts till now from any students of my teaching or any of the topics I cover. Okay, so see, here are the real world example where, yeah, in a classroom, if most students score between 60 to 90 on a test, but one student scores 10, their score is an outlier. Okay, because he has scored very low compared to most of the people. Uh, this could be due to a genuine lack of understanding, or like truly low performance. Like, which is a lack of understanding, or it can also mean an error. So it depends. Also in business, this would be it. A small local coffee shop typically sells, 200, 100 to 200 cups uh, per day. Okay, but on a particular day they sell 1,000 cups. So this could be an outlier, or there could have been any event, special event. So they sold actually at that amount, right? So this is actually a real world examples. So similarly, I've told you to study about the real world examples for biases. Have you guys any? Have you guys read about the real world biases? Nope. Okay, one no. Anyone else? See, even if it's no, it's fine. But just keep in mind to research on that. When you actually research on the real world examples, you'll feel interested to study about the data analysis. So out of all this, when I told you about the real world example, you understood the concepts. So unless you understand the real world example, you will not understand the real world concepts. Okay. So please do search about the biases as well in the real world concepts, and all the topics what I've done. Uh, just search the real world examples. Okay. See, I here it's the histogram continued. I guess the order has been mismatched, but you can understand it anyway. Okay. Reasoning. See here you can see this is the distribution of weekly self-study hours. Okay, what people do. So see, so here what you can see is there are majority of the people who are doing self-study. Majority of the hour is 15 hours, right? So there are people who do so much. Okay. So yeah, so in this the central tendency is like the majority of the students between approximately they do 10 to 20 hours per week, right? So can you see this dotted marks? So this here tells the central tendency. Central tendency is nothing but people who are in between. They are not extremely they less, or they are not doing extremely more. That's called central tendency. Most of the time, while doing the market research analysis, people look at central tendency. Okay, which means, for example, let's take sales of an electronics. Okay, so in electronics, when you buy something, for example, let's take earbuds or headphones. Uh, what are the what are some features you would be wanting in that? Can you can tell this, okay? Because if you don't tell this, I'll just close the class and sleep. Because everyone have earbuds, and at some point in your life, you have seen the features what you want in the earbuds. Even everyday life contains data analysis and data science. It's just the way you look at things. Nobody is answering. Okay, we'll close the class. Yeah, battery life. Then,
Sir, brand,
Okay, sir.
huh?
brand,
Yeah, brand we look at. Correct.
price.
Price we look at. Then we look at features like how is the bass, how is the volume, and noise cancellation. Then we look at yeah, as someone said, battery life, sound quality, true, right, and the price range, and colors. Like even if you look deeper, the colors, the design, because even the earbuds come in like the medium and micro sizes and all, right? So while for example, let's take a company Bolt or Go Bolt right now. So if we take that company, and let's imagine you are in the marketing team. So first, when you do tell the team to do the new model, the things what you have to consider is the central tendency. In the data inside, what you have to consider is central tendency. So, there the central tendency would be like if you come to the features, what is the feature people use in some range to some range? Like for example, uh, the regular people won't be needing the high bass or some specific sound requirements, right? So it will be either used by like high quality musicians or some DJs. So in your regular headphones and the headphones used by DJs or headphones used by musicians, there is a difference, right? So that will be analyzed by the marketing team and the central tendency of any particular features. So the central tendency comes in every features, like it might be in color, it might be in price. So when the marketing team decides the price after looking at their cost, the manufacturing cost and all, what they do is they look at the price range of other brands and what people like to and from which price range to which price range people like to buy. That which price range to which price range is nothing but a central tendency. So that's how histogram works. Okay. See, you can do the histogram for just one particular frequency and one column, uh, or you can do it for every column and just do the experimentation, and you can understand how the data works. Okay, so if you do it for every column in the data set, you'll understand uh, uh, how it's distributed. In the dashboard, you don't have to keep it all. In the beginning, whenever you get the data, you should always have the curiosity to play with the data without uh, without losing the data. Okay, so yeah, there were lot histograms which was misplaced in between. Okay, so it's here 9, 8, 7. Okay, sorry, it's my bad that my cells are just jumbled up. I don't know how, but we'll see. Uh, we'll go ulta, okay? Just don't mind if you don't mind, okay? We'll start with box plot because here, these are the things comes after the visualization. First, so I'll do this first. Okay, what is box plots? So box plots are nothing but it summarizes the data using median, quarterly, and highlights outliers. Okay, that's what box plot does. Understood? Or should I explain it again? Okay, nice. There there was a box plot that I can't find. I have missed it. Uh, okay. So when I send you the notes, I'll rearrange it and put the box plot as well. Okay. Right now, the box plot is missing here. There is just the definition of box plot. Okay. Mm, okay. After box plot, we'll come to multiple subject comparisons. Multiple subject comparisons. How we do multiple subject comparisons? Okay. So why do we have to do multiple subject comparison? Is nothing but I am not getting the definition what I've written. Okay, I'll rearrange when I send you the notes, but I'll tell you verbally. So which subject has more variability, or where do the outliers appear most? For that, we need to have multiple subject comparisons. So multiple subject comparison is nothing but you take one thing as fixed and you compare it with the different types of uh, columns. For example, in this histogram, if we keep all the histogram in one place, at that time we could be able to do the multiple subject comparisons here. Okay. Sorry. 9, 8. Okay. So after skewness, we'll go to median and mode. Okay. So before I start with skewness or skewing, do anybody know what is skew data means? Just don't look at this and answer. No. Okay. Nice. So let me explain. So let me start with the normal distribution. Okay. So normal distribution is nothing but a systematical or symmetrical bell-shaped. See whatever the bell-shaped distribution you saw in the graph, right? So that is nothing but normal distribution. So a normal distribution is symmetrical bell-shaped distribution where most value lie near with the center. So as you can see here, so here most value is in center, right? So this is nothing but a normal distribution and line you can see here. So when most value lie near the center, we call that value as mean. And what are the key properties of normal distribution? Is it? So here, so the key properties of normal distribution would be mean, median, and modes. Then the shape of the curve, then no long tails on either sides. So here you can see there is a long tail on one side, right? So if it is uniform and you can see it, if it is uniform and in the middle it's higher, then then that we would call as a normal distribution. Understood what is normal distribution is? Okay. Now after normal distribution we would come to skewing. So skewness is, in simple terms, skewness describes the asymmetry of data distribution. For there are two types of skewness, okay, which is a right and a left skewness. So what is a right skewness? Which is right skewness is, we call it as positive skewness, and left is negative, as you can see here. So if you have long tail on the right, so here you can see there's a long tail on the left, or here even here it's long tail on the left. Here it's a long tail on the right, right? So this is nothing but a right skewness, and this is nothing but left skewness. So which is nothing but right skewness means mean is greater than median, okay, and left skewness means mean is smaller than median. Before I continue further, I hope you all know what is mean median mode, right? It's 10th standard stuff, and it's very much useful and very much used every day for data scientists. I mean data analysis. So why most data are skewed? So while the normal distribution is powerful and in theoretical in concept, but most real world data is not perfectly normal. So like you can see it here. Uh, they at any did you find at any place that there is a histogram or there is a histogram or distribution which was even, like both the side they were evenly distributed at every place? No, right? Either it was right skewed or either it was left skewed. So that's how real world data works. Okay. uh, So natural limits. Many variables have natural lower and upper bounds, which is either from 0 to counts from for 0 to hundreds. It depends, and even percentage from 0 to 100 itself. And age group, it always starts with 0. So it always has some natural limits, and there will always be a measurement process, like how data is collected or measured can introduce skewness. Next, okay, that is how what is skewness is. I hope you understood this, and here there is a detailed explanation if you want for the future reference. Okay, so what skewness actually tells you in real world is the central tendency. Okay, so central tendency, uh, whenever you find in the data set, whenever you find any data with the properly evenly distributed the normal distribution, uh, so and which measures the central tendency, we can rely on that central tendency if it is evenly distributed. So that's what skewness actually tells us in the POV of insights. Now coming to mean and mean versus median. Okay. So this how mean gets affected by skewness, and uh, everything is written here completely for notes purpose, but I'll tell you just in the layman terms. For teach If mean is equal to median, then we say it's almost near to normal. Okay, normal in the sense the data quality is good, or whatever the data we have is reliable. If mean is greater than median, then but then we can say it's a right skewed. And if mean is lesser than median, then we can say it's a left skewed. Okay, so the thing is, mean is always affected by the extreme values. So even for example, let's take your CGPA. That would be a best example to understand mean. Okay, some people may have in their first term had a mark or had a CGPA of 6, and while coming to the 8th sem, in the final sem they got, let's say they got the CGPA of SGPA of 10. So their CGPA will check that extreme value and give the middle CGPA, right? So when you cumulate the SGPAs, if your first and 8 terms are extreme, then you will be always you would be in the average position, right? So that's what mean does to the result, which means when you have extreme values, sometimes you can't rely on mean. Okay, right. Why me? Okay, now see when when you are in your B or in your schooling, most of the time you will be only looking at median. Or you will only looking at mean. But as you grow older, uh, or when you look at into the housing prices or range, you don't check in the internet that what is the mean price of any houses in this locality. Okay, uh, in this locality, because the pricing range varies from person to house to house, right? So there can be a minimum and there can be maximum. So you won't be able to fix your budget according to the locality. The best practice is searching the median. Okay, that's why we call most of the time median is robust. Okay, so median is nothing but the middle value, right? So middle value in a data set or any value are arranged in or it's arranged in order. So median is most of the time it's the 50th percentile, and there are a lot of advantages of median because it will sort out the list, and you won't be having extreme values. So that's what median does. Even okay, let me give you the best example and best advice. What I can give you, which is uh, from I guess, have anyone did anyone of you get placed or yet to be placed in any company? And just raise or give a thumbs up if any one of you are placed. It's okay because even I got placed after 8 months of after from my B and all. Okay, because during that period I was doing uh, freelancing. So just don't sit idle if you are not placed. So let me tell you the best advice or example. So whenever you apply for any companies or any roles, so there will always be a question while applying. What would be your expectation for the salary, right? So what you guys do is you say according to your expectations, right? Or you most of the time what you say is like you look at your friends CTC or LPA, then you say say to write that expectation. Am I right? How many of you guys done this? Just give thumbs up. You never applied for any job application at all? Okay, you have the. Uh, so people who have applied for a lot of jobs, they would know that every job application, there is a minimum expectation, salary expectation question, or even when HR calls you, he or she will ask that if like what is your minimum expectation, or they will directly tell you this would be the salary we would be giving you. So before applying to any role, what you should do is you should look up the role in the Google and ask the Google that what is the minimum what is the median for this role for as a fresher. At that time you will get the average all over the country, or the median salary given all over that country, and you can set your expectations a little bit higher than that, so that you won't be disappointed, and even the people who are hiring you think that you know your stuff and you have researched the industry. Okay, so that's how much helpful the median is. I guess I have dragged the class more than 1 hour today, but there are a lot of things I wanted to tell you today, apart from median. Okay, I have missed 10 to other. Okay, there is 10. Everything is jumbled up. I'm sorry. Okay, so how to measure the skewness? I'll do that today. Uh, if I drag the class to more than 1 hour, is there any problem for any of you? So the thumbs up means yes, or thumbs up means no. Yeah, okay. Yes, you have a problem. Okay, okay. Then I'll try. 1 second. I'll just open the chat because I don't know what you're saying. So okay, no, so continue. Okay, I'll try to do how much ever possible today. Okay, because today the topics were interesting, but I don't know how much good you felt I did. Okay, just give me a feedback. You can DM me, or you can just tell it here, because I want to know the feedback so that I could uh, make it better for your next classes, or I can just keep it at the same pace. So there is something called in most of the real-time analysis, like mean can be most of the time mean is misleading, like I said, and median is often safer. Okay, uh, when like mean is safer only when it's a normal distribution. If it is a left skewed, right or left skewed, then the safest option is median. Next, there is something called automatic skewness. Okay, automatic skewness calculation. So that command I'll provide you there, but I'll just explain what happens there. So when there is a positive value or right skewness, or I'll just explain it in the notes itself. Okay, if I tell it verbally, you won't be understanding what is automatic calculation. So just pardon me. Next we can say exploratory data. Okay, so I'll provide to day 4. There are a lot of things I want to tell about this about skewness and other things. Like there are different types of variates as well. Okay, those I will be giving it in the notes rather than verbally explaining, because it will be a lot better that way. So then there is something called scatter plot. Okay, scatter plot I have not done in this yet, so we'll do that scatter plot. But I'll tell you the definition of scatter plot. So scatter plot is nothing but it shows the relationship between two numerical variables by plotting one against each other. So most of the time, like if the points are clustered in somewhere, or yeah, like is there any upward trend? Like in down there are like little dots, and as you go further, the dot will be like increasing in this manner. So that you can analyze there. Like for example, if you take math scores, like and high reading. If you take that 2 point high reading, people who read more hours in a day, and if you take the math score of those people, you if you draw the scatter plot, you will understand uh, whether people who are reading like most of the hours in a day or in a week, are they having a good score in math or not. Okay, that's what scatter plot. That's what you can understand with the help of scatter plot. And today also I wanted to teach you the Seaborn, but I can teach you Seaborn as we progress in the next sessions. Seaborn is quite easy. It's nothing but it's a tool which you can. It helps to visualize it and makes it look even better. Okay. With the help of Seaborn, you can colorize it, or you can do the pie charts in very good colorful manner. Okay, it's almost 9:30. Oh, okay, I'll give you something to research on. Then I'll provide you with the notes. Okay. So what I want you to learn something new, which is uh, you learn what is correlation coefficient. Okay. What we did today was we saw the relationships between the data sets, right, or the columns, right. So in this correlation coefficient, you learn like you should ask the questions like what does strong relationship mean in numerical. So you'll understand how you can define the relationship. Then the second thing you can ask is can two variable look related but have low correlation, which is the for again the example, if you take off shark attacks and the ice cream sales, there you can see you feel that there is a correlation uh, between two variables, but there is not, right. So that's what you learn here. So I wanted to research on correlation coefficient. And one second. Another thing what you can search is, okay, the another thing what I want to learn and experiment on it too with the help of GPT or Gemini, which is hypothesis testing. Okay. So the main heading will be hypothesis testing. The other research, the research topic would be you can see what is hypothesis and what is null hypothesis, what does statistical significance mean, or where is hypothesis testing used in real life. Okay. So uh, hypothesis testing, the example would be, for example, if students with the test preparation score is higher, and how do we know, like it's not by chance, right. Sometimes sometimes people who don't study like no never studied at all might have a chance of getting high score by copying, but while doing the data analysis of their study hours and their score, if we don't find a relationship, or if we find a drastic change which is not possible, then you'll be deriving a hypothesis. So that's what I want you guys to look at. Okay. Now let's come to attendance part.